To illustrate the value of phase, a critical piece of the full equation that you simply cannot get from an FFT or a time waveform in the same way is to use the simulator input. We'll go ahead and take some data, move to the next unit, choir, go back, and we'll green to yellow to synchronize all units. Now we've taken all the data, and yes, we do have the full balloon diagram filled out for you where we can look at the different aspects of phase and amplitude, summarize it, and kind of show that it's in balance. But to better visualize it for those who do not know what the phase is all about, we added this animation. This animation shows the orbits. It gives you a nice trace, shows you how the shafts are moving relative to each other. We added a few features here because you don't know the amplitude of the data. This is the actual data showing how the shafts are moving relative to each other. We can change the speed. We can amplify some of the motion and the orbit sizes, shift them back and forth and zoom. Another way to look at it would be to take a look at it and bring down this motion and now see it as an angle. We can pop on and show how the orbits are moving relative to each other and look at it in various directions, top down, over to the side. This one really illustrates it quite well. These are how the two shafts are moving together, and a nice round, once around comes around. What comes around goes around, I guess is the saying, for imbalance. So that is a very classic, nice round orbit for imbalance. To illustrate how things would look from a misalignment perspective, I've modified the simulator for a new data set. We'll go ahead and take a new set of data, grab the data on the second machine, come back, move over for a synchronizing reading. These are triaxials, of course. And now I have all the data set taken, and we come back here and go to the animation and take a look at what, let's start over here in the single view. In the single view, we see a very different pattern. It's not the round pattern of imbalance, but it's very flat and angled, very angled kind of a look, which is a classic sign of misalignment. Again, you cannot see this kind of information or motion because it's relative to multiple points in a given instant in time for a given frequency. That's what phase is. And you can't see that in an FFT. And take a look at the other views. Look at it from different angles, but the axial is quite effective in that, and we see this very specific pattern going on, which is a classic pattern for misalignment. So very helpful for showing managers and non-technical people exactly what is happening to those shafts and why the diagnosis is that it's misaligned or imbalance.